Hi, I'm Rich with Inside HPC. We're here at ISC 2017 in Frankfurt, and today we're at the NVIDIA booth with Keith. Keith, welcome to Germany, but let's start at the beginning. Who is NVIDIA and who do you help?
So NVIDIA is famous for our GPUs, and how we help people is by delivering our accelerated computing model, so GPU computing, which is the hot thing now. And we help people because we make their applications go faster and also save them money.
Well, there's a lot of that going on here, but what are you showcasing this week for the HPC folks at ISC?
Well, quite a few things. Let's talk about our current generation GPU, the Pascal generation. That was released last year, and it's being deployed in supercomputing centers, HPC centers, over the past year. And with the top 500 list that was just released, the significant thing was we had 13 of the top systems on the Green 500 list. So all top 13 of the most efficient systems on the Green 500 are accelerated by the Pascal P100.
And in fact, you also, in the top 10, you knocked the US out of the top 3 when you upgraded the Piz Dint machine in Switzerland.
Yeah, so now Switzerland's number 3, so that's all based on Pascal, which is great.
That's great. Okay, so what else this week came out?
Okay, so one of the things is at GTC we announced our Volta GPU, which we got one here. So for HPC, we increased the performance by 50%. So in 1 year, we increased the performance for HPC applications by a full 50%, which is pretty amazing. When you consider standard CPUs are starting to flatten off at the end of Moore's Law, it becomes even more important to think about an accelerated computing model. And so that helped HPC, but it also added a new feature called a Tensor Core, which enables to dramatically increase the operations for deep learning. So we increased HPC by 1.5x and deep learning by 3x in 1 year.
Is that on the training side or the inference side, or both?
That's on both. So for both training and inference, the Tensor Core improves both those by 3x in this generation. So another major step forward for us.
And then as far as Volta, this is for NVLink here, what you're holding, I would guess, right?
Yeah.
What about PCIe folks?
Right, so at the show we actually released the specs of PCIe. So the Volta GPU in SXM format was 7.5 teraflops, double precision, 15 teraflops, single precision, and 120 teraflops of deep learning performance, which is 16-bit inputs and 32-bit accumulate. And on the PCIe side, because it's a slightly lower power envelope, 250 watts, this is spec'd at 7 teraflops, double precision, 14 single precision, and 112 for the deep learning.
And will these be shipping later this year?
Yes, so the SXM will be available first in the DGX in Q3, and then it's becoming available from OEMs in Q4, and also all the major cloud providers are committed to include Volta in their services by the end of the year.
So Keith, just kind of a wrap up here. You've been in this industry a long time. What are you hearing from customers? What's going on?
I think the big thing now is people are really thinking about that AI supercomputer, so the combination of both computational science and deep learning. And it's that interplay of deep learning is a high performance computing workload, but also the deep learning as an application is very important for science as well. So we're starting to see people speed up simulations by, instead of maybe computing everything to completion, with enough training data they can infer how that simulation will complete, so they can speed up the iterations for example, drug discovery. So very exciting.
Well, what gets you excited about what's going on with HPC these days?
I think what gets me excited is the fact that everybody's talking about accelerated computing, so the use of GPUs to really get on that next trajectory so we can get to exascale. So if you look at you're just going back to the Green 500, it really shows we're on that track to be well ahead of the target of 35 gigaflops per watt that's needed to hit an exascale size system in a reasonable power envelope.